Okay everyone, now we are going to start to learn distance time graph, and I believe that all of you have learned this before in Sec 3. Okay, so first of all we will do a very quick recap at what is going to happen for this. Okay, so first of all you are able to see that this is a distance time graph which is divided into 4 regions A, B, C and D. Okay, so for distance time graph, the first thing we are very interested to know would be the speed. Okay, so look at the slides over here. Speed is equals to gradient. So in short, if we are going to find the speed for, let's say, region A, we are just required to find the change in the y divided by the change in the x. Okay, so if you are going to do that, let's just look at part A. So in this case, the y difference is 20. The difference in x is a 1. So it will be 20 divided by 1 and we get 20 km per hour. So for region A, the speed will be 20 km per hour. Likewise, for region D, first of all, we have to know the change in the y and change in the x. So if we take a look at this, same thing, change in y is 40, change in x will be 5 minus 3. Okay, but this time around is a bit special. You will see that the slope is sloping in a downward motion. So this means that the speed or the gradient is a negative. So make sure you include the negative sign in your calculation. Now so far so good. Okay, but what is the problematic one is the next graph. Take a look at this graph whereby the distance time graph is no longer the straight line. Okay, it's going to be a curve. And how are we going to find the speed, let's say at 3 hour? Okay, so what you can see that is if we are going to find the speed at 3 hour, you should be able to see that speed is the same as gradient. So you have learned that in drawing a gradient for a curve, we first of all have to identify the point, put your pencil at the point and use a ruler to draw a straight line such that it is a tangent to the curve. So once you get the tangent line, what you need to do is you draw a triangle. Okay, once you have a right angle triangle like the one shown in the slide, you will be able to find the change in y and change in the x. Okay, next, sub in the value of the change in y and the value of change in the x. You will find the speed, also called the gradient, of this point at that instance. Okay, next we are going into speed time graph, and before we do that, just let us do a very quick recap of what we have learned in distance time graph. Okay, so just bear in mind that the gradient in a distance time graph is to measure the change of distance with time. So that's why the unit is meter per second or kilometers per hour. Okay, now let's look at the speed time graph. You will notice that this time around, although the graph looks exactly the same as the previous example, you can see that the y-axis now is changed to speed and the units is kilometers per hour. Now if we are going to take a look at this graph, what does the gradient mean in this case? Is it going to be measuring speed again? No, because this is a speed time graph and not a distance time graph. So what does the gradient in this graph means? Okay, actually the gradient in this graph is measuring the change of speed with the time. So if we are going to do a very simple units comparison, you'll be going to see that you are using the y-axis, unit is kilometers per hour, divide by the x-axis, which is the time. So eventually you get the units that you obtain would be kilometer per hour square. So if you are measuring meter and second, it will be meter per second square. So physics students, you might be able to get it, which you have learned it in physics already, and that unit represent acceleration. Now let's take a look at the following graph and do a very simple example. Look at the graph and focus at the region A. Okay, for part A, to find the acceleration is to find the gradient. So we are going to use the change in y over the change in x. So very simply, we are going to use 20 divided by 1 to get 20 kilometers per hour square. That would be the acceleration for part A. Take a look at part D. The gradient in this case is a negative as it slopes downwards. So in this case, we are finding a deceleration. Workings will be the same as we are going to use the change in y over the change in x. Okay, final answer would be 40 divided by 5 minus 3, which you will be getting 20 km per hour square. So be mindful that deceleration, sometimes also known as retardation. In some instances, acceleration can be negative as well. So if you see a negative acceleration, it also means that it's deceleration. Okay, now in the next video, you'll be able to see that how distance is being calculated using the area of the graph, and the graph must be only speed time graph.
Calculate the distance travelled. The distance travelled is the area under the graph. Okay, so if you calculated all the area underneath this graph, that would give you the distance travelled. And we could do it for various parts. So let's do it for this part here, which I think I previously called section B. But the distance travelled between 10 and 15 seconds, all you would do is you'd calculate the area, and the area for this shape here is simply given by the length times the width, okay, or just times in two sides together. So from there to there, we've got 10 to 15, so that's a distance of 5, and from there to there is 0 up to 20. And simply to calculate the distance for that section, you would just multiply 5 by 20 equals 100, and as its distance, it's meters. Now if you think about it, that kind of makes sense, because we are travelling between 10 and 15 seconds, we are travelling at 20 meters per second for 5 seconds. So every second we travel 20 meters, so after 5 seconds it makes sense that we have travelled 100 meters, and that corresponds with the area under the graph here. Okay, a second place where we could work out distance travelled, where it's slightly more confusing, is say from 0 to 10 seconds. Now we haven't got a square here, we've got a triangle, and the formula for the area of a triangle is area is half of the base times height. And unfortunately, they don't give you this formula in the exam. You'll have to remember it from your math lessons. Okay, so for part A, this section here, the distance travelled is half of the base times height, so that would be half of 10 times 20. Okay, so I'm using the base distance as 0 to 10, so that's 10, and the height as the velocity change from 0 to 20, so that's 20, and we can squeeze that in over here. So 10 times 20 is 200, and half of that is 100. So the distance travelled is just coincidentally 100 meters. So that's how you calculate the distance using a velocity time graph. The only other section that might be slightly complicated, I haven't actually seen this in an exam, but might be worth looking at. If you wanted to work out a distance travelled between 15 and 20 seconds, you could just simply divide it into a square and a triangle, work out the areas individually and add them together. Okay, so that's how you work out the distance travelled from a velocity time graph and the acceleration.
Okay, now it's homework time, and you're supposed to do exercise 2B, page 60 of the textbook. Okay, do the questions 1, 3, 5, and 7, and hand in at the end of the lesson. What I want you to do is at least try the questions. Ask the friends around for help if you are stuck, and at the end of the day, pass it up to me so I can grade it as a homework. Okay, and see you for the next lesson. Bye.